Here we are again at the Institute of Enclosures. Welcome back. I'm Phil Taylor.
No, Phil. It's the Enclosure Institute, not the Institute of Enclosures. That sounds like a prison. Anyway, I'm Jimmy Budd.
All this time at the Institute of Enclosures, we've been talking about sealing the enclosure. We've talked about a wide variety of materials that can be used to seal. We've talked about how those materials might fail. We've talked about even ways that you can test your seal and predict its long-term performance. But today we're going to focus on something a little different.
For some types of enclosures, sealing them so well that they're airtight, dust-proof, and leak-proof can actually put the enclosure at risk. Those enclosures need to vent. So today, we're going to discuss a variety of venting solutions that may apply to your enclosures.
Typically, the electronic elements within an enclosure create internal heat that, if not controlled, may cause the components to malfunction. If you're as old as I am, you might remember the big fans in desktop computers that buzzed and whirred behind the louvers in the computer cabinet. That was a vent, sort of. It forced hot air out and cool air in. But of course, that vent would not keep dust and moisture from getting inside.
What Phil is trying to say is that one purpose of a vent in today's well-sealed electronic enclosures is to control internal temperatures without sacrificing the seal. The spinning fan inside of Phil's old computer is what we call forced air ventilation. Most relatively small electronic enclosures utilize a passive air ventilation design. We'll talk more about those in a few minutes. But the need for ventilation goes beyond simply heat or temperature relief. The increase in temperature is accompanied by an increase in the internal pressure and the buildup of moisture in warm air.
A proper vent will, first of all, allow for pressure equalization. Atmospheric pressures are constantly changing. The pressure within an enclosure is constantly seeking equilibrium with the atmospheric pressure beyond. This is why the half-filled water bottle that I took on the airplane started to implode by the time we touched down.
Inside the device, the rising temperature will increase the pressure within. Conversely, cooling temperatures will create negative pressure. These changes in pressure put stress on the device's seal. This can cause leaks, which could mean failure to achieve a desired IP or NEMA rating. A proper vent will also help control the buildup of moisture and condensation within the device. Trapped moisture can corrode the electronic connections and circuits. If the device has visual components such as a lens or a glass cover, the buildup in moisture will cause fogging. By allowing air to flow into and out of the device, the humidity level can be controlled, minimizing these sources of failures.
For example, let's talk about an automotive headlamp assembly. Automobile headlight design and manufacturing has changed significantly since I was a kid. And yes, Jimmy, there were automobiles when I was a kid. Whenever the headlamp went out on our station wagon, my dad would just take off the lens and pop in a new light bulb. But light assemblies in today's automobiles are made of injection molded plastic and thermoplastic enclosures sealed tight with LED or halogen light assemblies encapsulated inside. They almost universally include vents to allow pressure equalization and management of moisture and heat. The vent in the headlight assembly works like my new and very expensive rain jacket. It allows my body's heat and moisture to escape while keeping me dry from rain.
Now that we've established why a vent is needed in the enclosure, let's talk about vent designs. The first thing you need in your sealed enclosure is a hole, but you will then need to plug or cover that hole with the correct material that allows air to pass while withholding moisture and dust. There are many manufacturers of molded plastic plugs that mechanically fill the hole and contain filter fabric within the plug, but for simple designs, a flat vent is usually all that's required and is much less expensive. Flat vents, also sometimes called adhesive vents, are comprised of 2 or more thin layers. The key ingredient is a specialized film or fabric that enables air to migrate but prevents intrusion of moisture and dust. This material is the central part of the vent, whether that shape is circular or any other. A pressure-sensitive adhesive or double-faced tape is then applied to the perimeter of the shape for bonding to the enclosure's wall. A vent of this design is lightweight and almost invisible. It can be installed easily and will bond securely when matched with the right PSA product for the vent film and the enclosure structure.
As you might suspect, there are many choices of venting fabrics and films available for breathable vents. Many are made from expanded PTFE membranes, which allow air to pass while blocking moisture, dust, and debris in one direction or both.
These ePTFE films can be combined with a backer layer to add physical stability to the extremely thin membrane. Most available choices are hydrophobic, in that they resist the passage of water, but others are formulated to be oleophobic, meaning they repel oils and other oil-based substances. These variations are usually intended for automotive applications or other instances when the device may encounter various types of oils. For example, Rogers' DeWalt division offers quite a few ePTFE venting materials. Here are just a few. Products DW373V and DW353V are ePTFE without a backer layer. Their product DW936V-06 has a backer layer of polyethylene, and their DW932V series has a polyester backer.
The important properties of the vent film are, first of all, the maximum recommended application temperature that the film will withstand. Secondly, the typical airflow to be expected, which is measured in liters per hour per square meter at 70 millibar. And the minimum water entry pressure, or WEP, which is measured in kilopascals, or kPa. Did I say that right, Jimmy?
Sure, but do you know what a kilopascal?
I have no idea.
All right. Designing an effective vent for an enclosure involves first understanding operating conditions of your device, such as the temperature change over time that is expected, the enclosure size, and the maximum internal pressure that can be tolerated. The engineers at Rogers and Marian can help you select the best fabric and design to fit your device. Here's an example. If you have a 10-liter enclosure that will normally see a 27 degrees centigrade change over the period of an hour, and your enclosure can withstand 0.5 kilopascals of pressure, then you'll need 1 liter per hour of airflow. Knowing that will allow us to recommend the venting material that gives you the best combination of airflow and water entry pressure resistance within the recommended temperature limits.
In addition to a breathable vent, there are 2 other types of vents that we want to briefly discuss. Those are burst vents and dual-stage vents.
A burst vent is typically made from a solid membrane that will not allow air or water or debris to pass, but it's designed to burst when the pressure exceeds a given level. A good example of devices that need this type of vent can be found in the cells of large automotive batteries or other energy storage systems. Burst vents help to mitigate thermal runaway events when temperatures reach dangerously high levels, causing the internal pressures to spike. A dual-stage vent is a combination of both. Typically made from a porous PTFE film, this type of vent provides pressure equalization during normal operating conditions, but will burst in to release the dangerous buildup of gases when the pressures exceed safe levels.
The selection of the adhesive perimeter is also an important step in the design of the vent. As a preferred converter for 3M, Tessa, and all other major manufacturers of pressure-sensitive adhesives and tapes, a converter like Marian can help match the best marriage between the venting material and the type and nature of your enclosure's wall.
The vent may be a very small part of your enclosure's design, but the proper design of that vent can make a big difference in the long-term performance of your device. Get your converter, such as Marian, involved in early design for the best results.
That's enough for today's session here at the Institute of Enclosures. I'm Phil Taylor signing off.
And I'm Jimmy Budd. Thanks for letting us vent. See you next time.